Dear students, in the last class, I discussed basic number system, what are natural numbers, integers, whole numbers and all, and we discussed some problems on that. In this video, I am going to discuss reminder, problems related to reminder, the divisibility rules, as well as the digit present in the power of any number and problems related to it. Very interesting problems you will find. Here, first of all, any number which you want to divide, that is called dividend. Here, n is dividend. You are dividing with some number that is called divisor. So, let us say you are dividing n with p, and here this is quotient. After dividing, you get some number here, remainder. Like 9, if you divide with 2, 2 4 side, remainder is 1. So 9 can be written as 2 times 4 plus 1. So that's what division algorithm. You are dividing A with B, some quotient. A can be written as BQ plus R. Remainder is always less than divisor. Divisibility means that remainder happens to be 0. Then you'll have A equal to BQ. So A is a multiple of B. And a number is divisible by 2 if the last digit is divisible. Like 1, 2, 3 you take, it is not divisible by 2 because remainder you get. So if last digit is uh, any number, even number is there. So that is 2, 124, 126. All these numbers are divisible by 2. Last digit is divisible by 2 or any even. A number is divisible by 3 if the sum of the digits of the number, like 111 you take. So it's divisible. 3 is 9. So without dividing, how we can say sum of the digits is 3 is divisible by 3. Hence the given number is divisible by 3. 4 means 102 you take, it is not divisible by 4. Even you divide and observe it. 8, here it is 22, 2 is the remainder. So divisible by 4 provided last two digits like 112. This 12 is divisible by 4, hence this 3-digit number. 3-digit or any 5-digit doesn't matter. 48. These two digits are divisible by 4. Hence this 5-digit number is divisible by 4. So a number is divisible by 5. Here 125 you take. So last digit is 5. It's divisible by 5. Or 0. 120 you take. It's divisible by 5. A number is divisible by 6 if it is divisible by 2 and 3. Like if you take 122, it is divisible by 2. But is it divisible by 3 means I can write here 5. Sum is not divisible by 3. Right? Hence this is not divisible by 6. So you take 132. It's divisible because sum you take 5 plus 1 6. It's divisible by 3. Last digit is even number divisible by 2. Hence it is divisible by 6. So divisible by 7. Suppose you take a number 7 714. You know that it is divisible by 7. But procedure here is Difference between twice the unit digit is 4 here, and the given number and the remaining part of the given number. Remaining part is 71 minus 8, 63. So it's divisible by 7. Hence we say it is divisible by 7. One more example. 1, 2, 3, 5 if I take. Divisible by 7 or not. You would take twice the number which is present in units place, 10. Remaining part, 123 minus 10 is 113, not divisible by 7. Hence, given number is not divisible by 7. So now here, a number divisible by 8 if the number formed by last three digits. 1864 is there. 864 is divisible by 8. 108 times. Hence, whatever may be the any digit number, we say that it is divisible by 8. For 2, last number should be even. For 4, last two digits must be divisible by 4. For 8, last three digits must be divisible by 8. The number divisible by 9, suppose if we give this divisible by 9 means sum of the digits 9 plus 3, 12 plus 1, 13. So this is not divisible by 9. Right. So here I will take 6, 3, 4, 5. 9 plus 3 to 18 divisible by 8. Hence, sorry, 9. This number is divisible by 9. The number is divisible by 11 if difference of sum of its digits is odd places. Here odd places are, these are odd places, these are even places. Sum of digits at even places. So here it is 1 plus 3 minus 3 plus 1. Difference is 0. Divisible by 11. So divisible either 0. Sometimes you may get difference as here I got difference 0. Difference is 11 or 22. We say divisible by 11. Here it is fourth power of any number. Like here 6 square is 16. 6 power 4 is 16 into 16, 256. And the digit is 6. Right. Any power 4 ends with the same number. Like here, any power, the 6 power 4. 6 power any number ends with 6. 6 power 1 or sorry, 36. 36 into 36, 1296. 6 power n ends with 6. 6 power 1 or 6 square or 6 cube, anything ends with 6. Similarly, 5 power n also ends with 5. 1 power n ends with 1. 0 power n ends with 0. So these are other than these remaining numbers. Here you take 2. 2 power 4 ends is 16. So 6 power n, you know that it ends with 6. Power n, it ends with 6. So 3 power 4 you take 81. So units place is 1. 3 power 4 whole power n, it's nothing but ends with 1. Similarly, 7 square 49. 7 power 4 you take 49 whole square, it ends with 1. So 7 power 4 power n definitely ends with 1. Units place will be 1. So similarly here 8 square 64. 8 power 4 64 into 64 ends with 6. So now 8 power 4 whole power n is 6 power n, ends with 6. So similarly here 9 power 4 uh, is ends with 1. 81 into 81, 9 power 4 whole power n, it ends with 1. So these are the basic properties or statements which requires to solve the problems, exercise problems. So whenever you are writing competitive exam, different kind of questions will be asked. First, you should be thorough with the all the basics to solve the problems. After that, strategies plays a role. A number when divided with 114, it gives some quotient, some reminder. But that reminder he mentioned it as 21. So n will be 114 q plus 21. So this is nothing but 19 into 6 into q plus 20. Same number, if you divide with 19, this is anyhow 19 multiple, it is completely divisible. Only to get remainder, you have to divide the remaining part with 19. So 2 is the remainder. Here the remainder, when odd square is divided, odd square means what are the odd numbers? 1 square, 3 square, 5 square, 7 square, right? 9 square. When odd perfect square is divided by 8. So 1 square, if you divide, remainder will be 1 with 8. 3 square, 9. You divide with 8, remainder will be 1. 5 square, 25, right? It divide with 8, you get 24, remainder will be 1, right? So 7 square, 49, you divide with 8, so 48, remainder is 1. Like that, even 9 square also same situation. In general, how to generalize, odd number can be expressed it as 2n plus 1. Like if n is 0, you get 1. N is 1, 2 plus 1, 3. N is 2, 5. All odd numbers can be uh, written in the this format. Square. You can write 4n square plus 4n plus 1. So this part is 4n into n plus 1 plus 1. Sum of product of two consecutive natural numbers is divisible by 2. 4 into 2, it is divisible by 8. So remainder will be 1. Here reminder when we divide with like a cube plus b cube, you can write a plus 5 plus b, a square minus ab plus b square. It is divisible by a plus b. Not only cube, a power n plus b power n is a plus b into something provided n is odd. That is very important. Here, 3 power 90 plus 5 power 90, I can write as 3 square power 45 plus 5 square power 45. 9 power 45 plus 25 power 45. So here is an odd number which is definitely divisible by 9 plus 25, which is 34. All right. When you divide with 34, remainder obviously 0. Here 10 power 1, you divide with 6, remainder is 4. Even 100 reminder is because last digit is 10, you divide with 6 reminder, you get 4 each time. Like this 99 fours you get. So 11 into 36. It is divisible by 6, hence remainder is 0. So this particular problem, n square leaves a remainder of 1 when divided by 24. What are possible reminders when n is divided by 12? So n square leaves remainder 1 means n can't be even. N is definitely odd number. When n is odd number, it's and it is divided by 12. Then possible reminders, 1 because it's not even. 1, 3, 5, 7, 9, 11. These are possible remainder. Remainder should be less than the divisor. Let us check. When i- uh, n is divided with 12, some quotient, some remainder. N is, I can write 12q plus r. When n square is 12q plus r whole square, 144q square plus 24qr plus this part is divisible by 25. So n square must give a remainder. It gives remainder r square. If it is r is 1, it is okay. R is 3. Here 3 square, but you should get a remainder 1, which is not considered. 5 square, 25. 25 when you divide with 12, 20, 24, divide with the 24, you get remainder 1. 7 here, n square in the sense, remainder is 49. When you divide with 24 into 2, yes, 7 is possible. And 9 square is 81. You divide with 24 372 9. So you cannot consider this. 11 square, which is 121, you divide with 24, you should get a remainder. So 1, 5, 7, 11 are suitable numbers. Here it is divisible by 88 means it is divisible by 11 and 8. So when it is divisible by 88, it should be divisible by 4 means 46b must be divisible by 8. So here it is sum of these three numbers should be three digit number should be divisible. 8 fives 40 64 b must be 4, right? Once b is 4, 8a 5 1 6 4. What is a? It should be divisible by 11 means sum of digits present in odd places 13 17 plus 4 21 minus a plus 7. This difference is 14 minus a must be divisible by 11. A you can choose as 3. 11 will be divisible, right? That should be a single digit number. Other number is 14. 14 minus 14, but that becomes a two digit. So now from this we can write A as 3, B as 4, AB will be 12. So what value of must x must be given for divisible by 11? So it's again same thing. 8 plus 9 plus x plus 5 minus 5 plus 7 plus 6. 14, 22 plus x minus 18. That is 4 minus 4 plus x. So x is 7. Then it is divisible by 11. Your 6x plus 8y is divisible by 8. So this I can write it as 2 times 3x plus 4y. Here multiple is there. That means 3x plus 4y is divisible by 4. Then entire number expression will be divisible by 8. Here he asking least values of x plus y. It is already 4y which is divisible. X you take least number that is positive. 0 is there, it is okay, but 0 is not positive. So the minimum number which is divisible by 4 is 4. So that is 12 plus 4y is divisible by 4. 4y is least when y is 1. So x plus y will be 4 plus 1, which is 5. The number A39K2 is completely divisible by 8 and 11. A39K2 completely divisible by 8 and 11. Here 9K2 which is divisible by 8 means here possible number, if I take for example 12, 8 ones 11, K value here is 1 possible number, and A39 1 2. So here A9 2 11 plus A minus 4. This must be 7 minus A. So when it is divisible by 11 means least value of A is 7. Then A plus K will be 7 plus 1, which is 8. To find last two digits of 7 power 45, one process is with the help of binomial. You divide this with 100. Whatever the remainder you get, that remainder will give you last two digits of the given number. As till 10th standard, we don't have binomial theorem. Let us observe the sequence. 7 power 1 ends with 0, 7. 7 square. 7 cube will be 49 into 7. 343. We are least bothered of third digit. Only let us take last two digits. 7 power 4 ends with 0, 1. 43 into 7. So last two digits. 7 power 5 again. 0, 1 into 7, you get a 0. So for every 5 digits, we get 0, 7 in the first two digits place. That is 7 power 45. What he given 7 power 5 power 9. So definitely it ends with 0, 7. Here 2009, we can write 4 into 502 plus 1. 2010, also 4 into 502 plus 2. 2011, no need to write because every power of 5 ends with 5. Here it is 3 power 4 ends with 1. 7 power 4 also ends with 1. 3 power 2009, we can write 4 into 501 plus 1. 3 power 4, 501 ends into 3, ends with 3, 1 into 3. 7 power 2007, 10, we can write 502 plus 2, 7 power 4, 5002 into 49. It ends with units place is 9. Again, 5 power 2011, 5 power anything ends with 5. So final answer is this ends with 3. This ends with 9. Again 5. So units place is definitely 5. Or any odd number is multiplied. This is 3 power odd is odd. 7 power any number is odd only. Odd into 5 ends with 5. That way also you can answer it. Here 75 you can write 2 into 37 plus 1. So suppose here if I say 37 plus 1 whole square, you can write 37 square 2 times 37 plus 1. Once you divide with 37, this part is divisible, remainder is 1. Based on that 75 power 75, we can write 2 times 37 plus 1 whole power this. It is nothing but 37 multiple plus 1. When you divide with 37, this part is divisible by 37. Remainder you get is 1. So 45 means it should be divisible by 5. This can't be the answer. And it should be divisible by 5 and 9. 9 means sum of the digits should be divisible by 9. Here 13, 14, 18. Yes, it is divisible by 9 as well as 5. Here if you take 10 plus 9 plus 8, 19 plus 8. Okay. 27. This is also divisible by 12. Both can be answers. So product of two consecutive numbers is divisible by 2. Whether it is 1 into 2 or into 3 into 4, it contains definitely one is odd, other will be even divisible by 2. Product of three consecutive numbers is divisible by 3 factorial. Factorial in the sense product of three consecutive numbers. So product of 4 consecutive natural numbers, n into n plus 1, it can be any natural number is divisible by 1, 2, 3, 4. That is 24. You have to find last two digits of this 3 power 4 whole power 100. 3 power 4 is 81. So here 81 uh, whole power 100 we can write. So or we can let us write it as 3 square power 200. It is 9 power 200. 10 minus 1 whole power 200. So once you raise to the power 200, uh, except the last term, all are 100 multiples, like 10 power 200 something here. This will be 100 multiple. So the remainder is 0, 1. Next class, we'll discuss some more interesting problems as well as I will concentrate on the properties of